So good morning, everybody. I'm John Wares. I'm president of the Friends of the Georgia Museum of Natural History and also a curator at the museum. And a little over a year ago, we had the idea that um, there are lots of seminar series at a university, and a lot of times they're uh, they're driven in ways that use museum specimens or use the natural history involved, but maybe the outcome isn't specifically about the biodiversity and the natural history that a lot of us are in love with. So we have this talk series specifically to highlight biologists who either are associated with the museum or are doing, sort of parallel projects that really explore and expand our understanding of biodiversity in the Southeast and beyond. So if you're here, you found the website. We've got a great list of speakers for this coming year. It'll be the first Monday of every month. We push it back a little bit in January so that everybody's back from holiday break, whatever that looks like this year. So check that out and please share it with your friends. This week, we're really pleased, or this month, we're really pleased to have Dr. Matt Callaham from U.S. Forest Service. I've known him for about 3 or 4 years, and I've gotten to know a lot more about the really cool work that he does, exploratory work with the earthworms and soil fauna of the eastern U.S. And so I'm not entirely sure which side of all of that expertise he's going to fall on today, but I'm really looking forward to it. And I really appreciate you taking the time, Mac. So I'll turn it over to you.
That's okay, John, because I'm not sure which side it's going to fall down on either. We did put together a few slides, so I think that'll make it a little bit easier for folks to follow. So I'm going to try to share my screen. And thanks for the intro. Thanks for the opportunity. This is a group of people that I have long associated with. Bud Freeman and Dak Crosley and others have been really influential in my career. And so this is a great opportunity for me to tell you guys a little bit more about what I'm doing. Did that show? Okay. And I'm going to do this. All right. So fairly general topic today, earthworms of the Southeast. And so what I intend to do is give an introduction to the audience, basically who they are and what they do. And I hope we'll have lots of time at the end for questions and answers, hopefully some reasonable answers. And so we'll see how it goes. I have to do this because I'm a USDA employee. It may appear that the speaker is making recommendations regarding policy for the management of public lands, but the views expressed are my opinion only, and they do not reflect any official position or policy of the USDA or subsidiary agencies. All right, so my objectives today are to give a little bit of natural history of earthworms, kind of why you should care about earthworms in the first place. And then I'll have a little section in the middle about some work that students and postdocs and I have been doing on regional biodiversity of one of the native groups of earthworms in the Southeast. And then at the end, because I'm an ecologist, I can't stay away from talking a little bit about the ecology. So that's the what they do part of the talk. So why should you care about earthworms? So the first answer is that earthworms are ecosystem engineers. And if you're not familiar with that terminology, what that means is that earthworms have the capacity through their feeding and burrowing activities, they can modify their habitat so that it makes new habitat available for other species that would otherwise not occur in the ecosystem. So these engineering effects can be physical, they can be chemical, and they always result in some kind of biological result that enhances diversity of ecosystems. So earthworms are well known to do this and engage in this kind of activity. So through their feeding and burrowing, they create habitats and they enhance the pore space inside soils so that many other organisms can occupy those soil volumes. And so we'll go into that a little bit, sort of the physical and biogeochemical effects that they can have on the environment. And the other thing is that earthworms live close to where you work. There are earthworms practically in every shovelful of soil in the entire eastern US. And I just find this really fascinating. And I think that most people have an innate fascination with earthworms. I mean, if you turn some kids loose in somebody's backyard with a shovel, they will find a worm and they will have some kind of a reaction to it, whether it's elation or disgust. Almost everyone has had some kind of direct experience with earthworms, and I kind of just have stayed in that infantile state for as long as I possibly could and studied these organisms for most of my career, off and on anyway. Okay, so getting a little bit more technical. So what you can see in this photograph is a little pile of pellets. And those pellets are the egesta of an earthworm that has been feeding in that soil. This picture came, oops, somehow I'm automatically advancing. This picture came from close to Milledgeville. And so what you can see is happening with these castings is that the earthworms are eating below the surface and then they deposit the cast on the surface. And if you can see, they're burying the materials that are on the surface of the soil. And you can see that this would have a major implication for the way nutrients get cycled in forest ecosystems where this kind of activity is happening in large quantities. And so this influences the water-stable aggregate structure of the soil. It influences the texture of the soil in terms of which kinds of particles are distributed where in the soil profile. Obvious implications for nutrient relationships. So as this organic matter, which is rich in nutrients, gets incorporated into the soil, it becomes available for plants and other animals that need those nutrients. So I think this is fascinating. So a little bit more into feeding and burrowing. So when earthworms burrow through soil, they can also influence the pore space in that soil. And pore space is directly related to things like how gases move in and out, how does oxygen penetrate into the soil, how does CO2 leave the soil. Their physical effects can have influences on mineral weathering, they can influence soil pH. All of this combines to influence redoxomorphic relationships.
Mac,
Yeah,
can I ask a question?
sure.
I had just heard a Radiolab episode that was talking about mycelia and how they supply mineral nutrients to plants. Is there like a known interaction between earthworms and bioturbators and how fungi are able to access that?
Yeah, there are interactions between earthworms and fungi. Earthworms eat fungi, so it's well known that. So if you were to take a electron micrograph of the ingesta, the stuff that earthworms are actually bringing into their digestive tracts, they have this organ in the digestive tract called a crop and a gizzard. So it's just like a chicken gizzard, right? They use that musculature to grind things up. And so there are existing studies where they've looked at, sort of what the fungal mycelial content of that ingested material is. And so in the foregut, it's all, it looks like fungal mycelia. And then after it goes through the gizzard, it's just ground up into tiny pieces, right? So we have this concept that earthworms are grazing on fungal mycelia, at least in part. And so that often has the impact of, or a similar impact to like pruning. So if an earthworm prunes the mycelial mat or the length of mycelia in a soil volume, it often results in a proliferation of additional mycelia after that's done. So it's a kind of a pruning, if that makes any sense.
Yeah, that's great. That's really cool. Thank you.
There are some strong influences. And so my student, so you guys will have to stay tuned, my student Melanie Taylor and Nina Wurzberger and others we're in the process of designing an experiment to look at, in particular, mycorrhizal associations as influenced by earthworms, both native and non-native earthworms.
Oh, that's great.
So yeah, that's a few years down the road before we'll have anything definitive. But we're kind of going down a very interesting path, looking at a number of different factors that are influencing forest soil processes, including those questions. So yeah, so this behavior has all kinds of chemical, physical, biological effects, I guess, is the short way to say it. Influences water infiltration. The burrows can create preferential flow paths for water through the soil matrix, and so on and so on. You know, that there's virtually no soil process that earthworms don't influence. So that's why you should care. All right, so now I'll move on to, this is a little bit disjunct, but the work that we've been working on in our group, probably with the most intensity with relationship to earthworms lately, is this this group of earthworms called the Sparganophiladelphia. And these earthworms are kind of semi-aquatic, so they live along the margins of stream beds and lake beds all over the eastern U.S. and down into Mexico as well. And so we've been calling it the tragedy of the Sparganophiladelphia because it's a classic case of not my job. So all the terrestrial folks think that these are aquatic earthworms, and all the aquatic folks think that they're terrestrial earthworms. And so as a result, there's been very little, you know, sort of biodiversity work done on them. There's been almost zero ecological work done on this group. And so it's a really interesting situation. So I have several, believe it or not, several aquatic ecology friends, and they basically say some version of this. It's like, oh, those are the things we step over when we're getting into the stream to do our work. And so I think that this is a really interesting group, and we're lucky that we recognize they're there so that we can do some of this work. So this is what they look like. You can see this worm here. I think they're really striking organisms. They have this habit of curling up into a corkscrew whenever you extract them from the soil. But what we're really interested in is these little piles of castings. And so the next time you go out on a walk anywhere in the Piedmont where you're close to a stream, I encourage you to just take a look at the margins of that stream, either on little sandbars or little places where leaf packs or sediment is collected. And I can almost guarantee you that you will see these little piles of castings if it hasn't rained in a while. They do get disturbed by rain. But these earthworms are as close to ubiquitous as any organism in terms of being able to predict where you're going to find them and when you're going to find them. They are there in most aquatic ecosystems unless they're really heavily impacted by pollution or some other issue. And so we find them in coastal plain streams, and we find them all the way up into the highest reaches of the headwaters of these Appalachian streams. And so they're really an entrenched part of the fauna, the soil fauna, and I guess stream fauna for the region. And so it's surprising, I guess, a little bit that nobody's really looked at them that much. So I had this postdoc come over from Japan. His name is Hiroshi Ikeda. And so we embarked on this really extensive sampling of Sparganophilus worms. And so every green dot on the map is a place where we sampled at least, it is a state in which we sampled at least one location, but usually several locations in each of these states. And what resulted was an extensive collection of more than 2,000 specimens. And I should mention that these specimens are sort of in the process of being incorporated into the collections at the Georgia Museum. And John's really excited about that, and we're really excited about that because it's important for us to make sure that these places, or that these specimens wind up in a place where they'll be taken care of and available for future study. And so what Hiroshi did was he did a phylogenetic analysis of these worms, and what resulted was that we basically have many undescribed specimens, possibly undescribed genera, and at least a dozen or so new species. This is based on Hiroshi's analysis, which is admittedly fairly conservative. I'll show you a little bit more about how conservative we think it is. So anyway, just a little bit about our methods. We just drove all over and sampled in as many of these watersheds in the east as we could, with the hypothesis being that big drainages would have their own endemic species of Sparganophilus, because these worms can't easily go overland between watersheds. So we figure if they've been in place for sort of evolutionary time, then they should have radiated and speciated in their own drainages. So here's what the results look like. This may be a little technical, but most of you probably can get the gist of this. So these are species area curves for the extensive sampling that Hiroshi did. And so the bottom line is that if you look at the number of sites that we sampled, which is along the x-axis there, and the number of molecular species that we turned up, you can see that we didn't get even close to saturation on these two latitudes. So there's a little bit of a relationship between species diversity and latitude with earthworms. And I don't know if I really want to get into that right now, but the point here is that, you know, we sampled 10 spots and we came up with 8 species, which is more or less a fairly close to a 1-to-1 ratio of species per spot. And what you look for when you're doing these kinds of analyses is this kind of dark green curve here, which sort of flattens out, right? Which suggests that in the 28 to 32 degree latitudes, we found most of the species that we're going to find there. But if you look at these lower latitudes, and particularly for the Diplocardia worms, this is a different group of worms, we didn't even come close to discovering the diversity that is likely to be there. So this is pretty exciting. I showed these Diplocardia. This is a different group of worms, and we can talk about those later too if you're interested. But for the moment, the message right now is that we're not even close to discovering the diversity that's there. And we need to do more, although it pains me to say it because we drove almost 20,000 miles when we were doing that sampling. We didn't even come close to scratching the surface, so we got to go back and do more. All right, so that was Hiroshi's work. Now for my other student, Roberto Carrera, who was the most recent worker in this group. So what we decided we would do for Roberto's work was, rather than do this giant extensive sampling, we would try to focus in on one particular spot in the landscape. And so because we live in the Piedmont and because we have several experimental forests within the Forest Service network that are located on the Piedmont, we thought we would do a very intensive study of these worms, both in space. So in other words, we're sampling multiple reaches along a given watershed. But we also wanted to do a fairly intensive sampling within time, because we know that not all the species that are present in a spot will be active and sampleable over at one particular time of year, if that makes sense. So we might get a different group of species if we sampled in the fall relative to the group of species we got in the spring. And so this formed the basis of Roberto's master's thesis. And so Roberto is kind of an old school guy, which is interesting because he's only 25 years younger than me. And so he was really interested in doing morphological descriptions and didn't want to focus on the molecular, although we are using a molecular approach to further probe the findings. And so this is kind of this is really to me, the most interesting slide of the entire presentation. So we sampled in these 3 different watersheds on the Piedmont. One of them is at the Callaham Experimental Forest in South Carolina, one at the Skull Shoals Experimental Forest, which is just south of here, and one at the Hitchty Experimental Forest, which is in a different watershed. That's in the Okmulgee watershed, or Okmulgee drainage, whereas Skull Shoals is in the Oconee drainage. And so what resulted was these 10 new species, or 10 species that are completely new to science. And so Roberto has done all of these morphological descriptions using fairly standard traditional techniques, but it's inarguable from a morphological standpoint that these represent new species. And so essentially what we did was sample across a year for 1 year very intensively in 3 different watersheds, and we turned up 10 species that were unknown to science. And so the sort of, I don't know, you could despair if you think about how many species you might turn up if you sampled over here in the Chattahoochee drainage, and then in the Coosa drainage, and then in every other drainage that's across this region. It's almost mind-boggling. So that's the kind of work that we've been doing, very descriptive. Essentially, it's biodiversity discovery. And there's not a lot of there's not a lot of, how do I say, funding available for this kind of work, and we kind of did this on a shoestring. But we think that it gives reason for pause, because we don't know what any of these species are actually doing in ecosystems either. And we think that that's probably where the rubber is going to meet the road. Okay, so we're learning who and where they are to an extent. We know at least sort of what we might expect if we could dig in every watershed. But what do we know about what these Sparganophilus worms are doing? And so being an ecologist, that's kind of where my interests really are in the first place. So just a little bit more background and natural history. I probably should have talked about this earlier, but it didn't really fit in terms of what our experimental design was. So most people are not aware. Maybe this group is different in this respect, but Charles Darwin's last major work was on earthworms, and this is the spine of that volume: the vegetable mold and earthworms, also known as on the formation of vegetable mold through the action of earthworms. And so Darwin made observations over the course of the last 40 years of his life at Down House in southern England on earthworms. And so I just read this little passage for you. It is a marvelous reflection that the whole of the superficial mold over any such expanse has passed and will again pass every few years through the bodies of earthworms. The plow is one of the most ancient and most valuable of man's inventions, but long before he existed, the land was in fact regularly plowed and still continues to be thus plowed by earthworms. It may be doubted, now this is an important passage, it may be doubted whether there are many other animals which have played so important a part in the history of the world as have these lowly organized creatures. And that's high praise for the lowly worm. And it was reading this as a young undergraduate that sort of made me convinced that it was worth my time to look at earthworms too. And so these are a few pages and plates from the text. You can see various different species and various different structures of castings. And so the one on the right, if you can see, I know you can't read it, but what that is one of the monoliths at the Stonehenge monument in southern England. And so Darwin argues that stone obviously was on the very surface of the soil at one point, but through the action of earthworms, both undermining the stone and casting their casts up against the side of the stone, that it will eventually disappear from the surface. And so that's just a testament to how much activity these earthworms can, or how much modification of the surface these earthworms can engage in. All right, so going back to the Sparganophilus and going back to our observations that they're making castings on the surface of the sediments on stream sides, we asked the question, okay, what does it mean in terms of processes that ecologists care about, like soil chemistry, water chemistry, and decomposition rates? So Roberto came up with this little experimental design. I'm not going to go into the details, but basically what we tried to do was see whether or not these earthworms would influence the decomposition of material from litter bags that were either placed on the surface or buried beneath the surface. And so we did this using a litter bag approach, which is you take a bunch of leaf material and put it in a screen bag and either put it on the surface or bury it and have earthworms or not. And so here's a picture of Roberto's hands in purple gloves. And that's one of our litter bags. And this is one of the worms that actually got into the litter bag over the course of the experiment. And just a little teaser with the data, we're in the process of writing this up now. But if you look at on the left-hand side of the plot for the surface applied litter, the earthworms definitely had an impact on the amount of leaf litter that was remaining in those bags. So they're having a direct, measurable, significant effect on the disappearance of litter in those bags. And so that's not a surprise, but it's never been measured before. And so we think that this is going to inform a lot of things like stream chemistry and nutrient cycling and availability of organic matter for other organisms in stream ecosystems. And we're just kind of adding another piece to the puzzle that folks have been working on trying to put together for many, many years. Okay, so another thing that we care about in terms of these worms is they do have very interesting behaviors that are more akin to their aquatic kin than their terrestrial kin. And so I hope this video will work. So we kept them in the lab for a while, and this is looking through a plastic container. You can see, can you guys see my cursor at all? Yeah, okay. Well, so the worm burrow is right here, and when I set it to go, hopefully it'll work. So can you see the worm moving back and forth in that peristaltic pumping behavior? So that is classic marine sediment ecology. There's lots of marine sediment worms that do this behavior, but it's never been documented it's not been documented in freshwater ecosystems that I know about, particularly not lotic systems. And so why do we care about this? This worm is pumping oxygenated water down into these sediments. And oxygen influences practically everything that goes on from the biogeochemical standpoint in sediment. So just to give a little demonstration of this, so this top panel is an oxygen profile for sediments that don't have marine worms in them. And the bottom one is the same profile, looking at oxygen concentrations below the surface, and you can just clearly see it passes the ocular test that that these worms are having a major influence on the penetration of oxygen into these sediments. And so oxygen influences what kinds of microbes can be there and what those microbes are doing in terms of processing organic matter and virtually every other thing. Here's another example from another study. And so the sediments on the left are the ones that have earthworms, the sediments on the right are the ones that don't, and there's just a clear influence of redox conditions, and that will influence microbial community composition, microbial community function, and so on. So we think that the same kinds of things are likely happening in the sediments that are occupied by these earthworms. We just need to get a chance to try and demonstrate this experimentally. So that's pretty much it. Just want to point out that there is a lot of opportunity for continued work in the future. We need partners to do this, and I'm basically working by myself at this point because Hiroshi's going back to Japan and Roberto's going on for a PhD in Wisconsin. But we think there's lots of room for more biodiversity studies, discovery and taxonomic work, more basic life history type stuff. We need to take what we found in the lab into the field and confirm or deny that that's really happening in the real world. We need to conduct some food web studies. What exactly do these worms eat and who eats them are kind of the basic questions there. And then I think more studies on biogeochemistry of the castings and the burrows of these worms would be really fascinating and probably would shed light on some of the processes that we're trying to figure out for stream systems across this eastern US. And so with that, I'll just say thanks. And thanks again, John and Bud, for the opportunity. And this has been fun.
Right. That's great, Matt. Thank you very much. I know applause is a tricky thing to do over Zoom, but we've got a good crowd here. And if anybody has questions, this is a great time to talk to North America's expert on worms.
One of the top three anyway.
There you go. I know one I've got maybe to start things off is, so Mac and I connected about a year or so ago over the fact that there are a growing number of invasive earthworms in this area. So are these sort of semi-aquatic earthworms, are they not as affected by the invasive folks from Asia, or?
That's an interesting question. So there are some of the Memphis worms in particular that will get down into the same habitat, but they don't seem to be nearly as aggressive, so to speak, in terms of we find them occasionally, but not often. In that that exact habitat, which is right on the stream bed, right in the saturated sediments. However, we did in another another survey work that we were doing up in the DC area, we did discover a European species which is more like these worms in terms of living in saturated sediment. And that was the first time that genus had been recorded in North America. So whether or not it represents a threat is kind of up in the air at this point. But there are potential invaders for that kind of habitat. They just may not have gotten here yet.
Mary's got a question next.
Yeah, Mac, this is fascinating. Do you find these? Do you find Sparganophilis like in the where the water willow is emerging out of the water, or are they strictly up on the bars?
You should ask your colleague Tim Fritz about that.
Okay, I'm given that opportunity, I will. So let me ask you another question. Do you know how sensitive they might be to things like herbicides and Roundup? I'm working up there in the Conestoga River where we are seeing fish declines, and I'm interested about could these worms either be indicators, and then I'm also really interested in how they might be affecting ammonia and ammonium over in the edges where my larval fishes are.
Yeah. So we should have some nitrogen data from Roberto's experimental work, the lab mesocosm work. But I wish I could be more definitive about that. The data are kind of in limbo right now.
Okay.
The reason I say that about Tim Fritz is that he's got an unpublished data set where he measured these worms in exactly that kind of habitat.
Oh, really? Okay, that's fascinating. It's just such important habitat for little fishes, and there could be some interesting interactions going on.
So I would say that the potential to use these worms as indicators is probably pretty good, but I don't know because I have intentionally avoided sampling in heavily impacted systems.
Right.
We're trying to discover biodiversity, and so we're going to what we consider to be the least disturbed areas, right?
Sure.
But I will say this, I think that Sparganophilis, since they do love sediment, is probably the only group of native earthworms that have benefited from the impact of humanity on the landscape. I think they're probably more widely distributed now than they were before.
Interesting.
More abundant anyway. That's impossible to test, but maybe not impossible, but difficult to test. Because if there's anything humans do well, it's make sediment, right?
Right. Well, that's great, and the biodiversity work is fascinating as well.
Yeah. Well, let's talk about. I think some straight, aquatic or sediment ecotox work using these worms in the lab would set the stage for using them as indicators in the field, and
sure. It's cool.
Jeb, I think you're next.
Oh, thanks. Hey, Mac. I'm interested in the invasion aspect that John was asking about earlier. And having lived in New Hampshire before, we were always told all the earthworms here are non-native. But I never quite understood why. I understood why glaciation would be bad for worms, but why are they only recolonized by invasive species?
Yeah, that's a good question. So I'm glad you asked that, because if you go to my last slide, which I threw in there just in case, this describes sort of the southern limit of the Wisconsin glaciation. That's the most recent one, ended about 12,000 years ago. And so if you look at the gray area, that's where native earthworms, the shaded area, that's where native earthworms are known to occur, right? Mm. So they do get past the limit of the glaciation. It's just a very, very slow process, right? And so anything that got established above that glacial limit, was brought there by humans, right? And so there's 2 or 3 reasons why this is a slow process. The most important of which is that earthworms are slow, right? And so many of the native species they don't tolerate disturbance, for one thing. And so the suite of species that have come from Europe and Asia are ones that are inherently disturbance tolerant, right? They're the ones that are left after 5,000 years of agricultural development in Asia. or 2,000 years of agricultural development in Europe and the Middle East, right? Those are the ones that are left. We think there probably was an extinction level event of earthworm diversity when human cultures and agriculture in particular were developed in large landscape areas. So the worms that are left are the ones that are disturbance tolerant and can handle human activity, and they're the ones that came.
Yeah. And why could the natives, why did the natives worms not have an original range that went farther north? What was wrong up north?
They probably did.
Well, I mean, your gray area on this map to me is striking that it stops where it does and doesn't go like up into Canada, for example.
Yeah, well, it would have prior to the glacial activity. Right?
Oh, it did. Okay, I see.
Yeah, we think there's other things, right? So if you look at this black line, it also fairly well describes the glacial outwash rivers.
Mm-hmm.
Right? So it's tough for an earthworm to get from this side, which was okay when it wasn't covered in ice,
Mm-hmm.
to get to this side, which was not okay when it was covered in ice. So that's sort of a geological limit to their ability to expand north of that boundary.
Right.
There are ways, right? I mean, it could have been picked up by a bird or gotten stuck in the fur of a migrating bison or, whatever else. But those are pretty low probability events, we think.
Right.
So the ones that did get north of the glacial margin, they can only move as a population front without assistance from humans, right? They can only move about 10 meters per year.
Okay. And then would it be true there's no worms that live anywhere where there's permafrost? Is that right?
Yes and no. There are oligochaetes. There's not any megadryals, right?
Okay.
Enchytraids, you're familiar with that group?
No.
So they're little diminutive cousins of the earthworms. There are some enchytraids that can live in frozen soil, and there are a few megadryals that can tolerate being frozen part of the time. So they might be able to inhabit the superficial layers of permafrost soils, but it is a pretty strong limit for most species.
Thank you.
Sure.
Other questions? Mac, I will say that I went to the effort to put out some cover boards this year, but Scott Connolly can back me up on this. His hypothesis for why I've found nothing under the cover boards I put out is we got so much rain that it was actually drier under the cover boards instead of wetter. So
It will be.
No luck this year.
Yeah. Well, they're out there. Keep going, John.
Yeah. I'll keep looking for sure. Well, are there other questions for Dr. Callaham? And if not, I want to thank him. I really appreciate this. It was a lot of fun. As an intertidal biologist myself, I definitely appreciate organisms that get overlooked by the people on one side of the boundary or the other. And I'm looking forward to learning more about these as they get contributed to the museum too, Max. So that's great. Everybody who's here, please help spread the word. Pass along the website for the Turtle Pond Talks. I don't have it up right now to remember who is talking next month. There's too many things open on my computer right now. But it'll be the first Monday in November, which means the day before Election Day. So it'll be a happy event, at least one happy event that week that we can have. So I look forward to seeing everybody there. And also we're going to post the videos for this to the museum YouTube channel, so people will be able to learn a little bit more through that as well. So anyway, thank you very much, Mac.
Yeah.
Thank you, Mac.
Thanks, Mac. Enjoyed it.
Thank you.
Right on. Take care, everybody. And Mac, I'll talk to you soon about more earthworm news.
Okay, awesome.
All right. Cheers.
All right,
Cheers.